Last time I built a maze generator, a fun little project. But now I have to solve it. Manually solving mazes? Too much effort. I thought, why not make a program that finds the best path all by itself? Genius idea, right? That's what I thought too, until I actually had to do it. So I went down the rabbit hole searching for answers. And then I found it. A Medium article about A-star pathfinding. And it enlightened me about A-star pathfinding algorithms. Unlike other algorithms like breadth-first search, it doesn't just find a path, it finds the best path, the optimal way through the maze. It's like the chosen one of pathfinding algorithms. And so, my mission began. To save time, I decided to use my old maze generator as a base. Brilliant idea. Except errors. Of course, gave it a quick fix and it worked. The maze was back. And now it was time to make it solve itself. By using A-star algorithm, and here's how it works. Let's say here we want to reach from the green point to red using A-star algorithm. The A-star algorithm uses this formula. F equals to HN plus GN. Now,
what's that mean?
Here, GN is the cost of moving from one block to another. In our condition, this is a constant. No matter where you go, up, down, left and right, the cost is always 1. And HN is the heuristic value, which every node has. It tells us how far the node is from the end. It is found using this fancy formula and the end node. Now, combining this whole soup together gives us the F value. All right, let's get started. Now, suppose we start from the green point. We calculate the F value by summing the cost of moving, G, which is none at the start, the heuristic value, H, which is the distance to the goal, which will give us F value as 28. Next, let's say we move up. We get its G value, which is constantly increasing by 1. We calculate its heuristic value as well. Then we add them together to get its F value. And we repeat this again and again, checking every direction, down, left, and right. Then comes the key step. We choose the lowest F value and move towards it. Repeat it again, get its neighbors and their F value, and choose the lowest one and move towards it. And we keep repeating this process until finally we reach the end, the red point. Well, this is what A-star algorithm is. I wanted to see how well this algorithm works. So I cranked up the difficulty, added loops, more paths, more dead ends. Now, a star didn't just have to find a path, it had to think. It's time to stop yapping and start doing. All right. Step by step, plotted a starting point, added a way to detect walls for balls. Damn, that rhymes well. Found possible neighbors, meaning paths with no walls in between. Calculated G cost, H cost, distance so far, F cost, sum of both. Made sure it never backtracked or revisited processed nodes. Repeated this until it reached the goal. Sounds perfect, right? Yeah. But how could I ever forget about errors and more errors? Yeah, life is great. I tried fixing my code. Now let's check the results. Fixing that made me forget the A-star algorithm itself. Went to YouTube tutorial.
1 eternity later.
Okay, got it. Fixed one thing, broke 5 others. And WTF is going on here, but after a painful amount of trial and error, it worked. A star calculated the path perfectly. It was fast, efficient. Let's change the maze size. Bigger maze? Good. Damn, I feel like proud dad moment, which will never occur in our life. Now, how do I highlight the optimal path? Let's make it purple, because if I suffered for this, my maze better look fancy. I added this stuff's so-called shady backtracking method, ran it again. And that's what I'm talking about. But wait, let's add a little animation. And just like that, my maze now solves itself. No thinking required. Unlike me, who had to think way too much for this. If you enjoyed watching me suffer, hit that like button. If you want more chaotic coding adventures, subscribe. Alright, that's it for today. See you in the next one.